So in the previous example, we had a psi of x and t, which was 1 over root 3 psi 1 of x e to the minus I e1 t over h bar plus square root of 2 over 3 psi 3 of x e to the minus I e3 t over h bar. And we were considering, so this is the particle in the confined to the region x equals 0 to x equals L. And we were considering the probability, P, of finding the particle on the right-hand side of the well. So from L over 2 to L, so in this region, what is the probability of finding it there? That's, of course, psi star psi in dx from L over 2 to L. And we argued from the parity of these functions that this needed to be 1/2. And so we want to look more closely at the math to see what this looks like. So when we write this out, we're integrating from L over 2 to L. What is psi star psi? So psi star is the same thing as psi, except that this becomes positive, and so does this. And so then, therefore, we have three terms. The first term looks like 1/3 psi 1 of x squared. The second term is 2/3 psi 3 of x squared. And then we have the cross term. So it's two terms that involve square root of 2 over 3 times 1 over the square root of 3. So that's twice, what do we get there? Square root of 2 over 3. Psi 1 of x, psi 3 of x times the cosine of the energy difference. So that should be E3 minus E1 times T over H bar, where this is the angular frequency. And we want to integrate this. So let's put another parenthesis here. We want to integrate in dx. So what does that look like? Well, we have this first term. Of course, if we integrate from 0 to L, then psi 1 is orthonormal. When we integrate that, we just get 1. But the function has definite parity, so we must get that each side is the same. The function doesn't prefer one side over the other, so both sides must be the same, and the total integral must give us 1, so that must be 1/2. So we have 1/3. So if we had this by itself from here to there, that would give us 1/2, but we have a 1/3 there. So we have 1/3 times 1/2 plus 2/3. Right now we're integrating psi 3 squared and dx from L over 2 to L. Of course, if we integrated just that part in dx from 0 to L, that would give us 1 by orthonormality. But we're doing half of the well, and there's no preference of these functions on one side with respect to the other, so it must be the same on both sides. So 1/2 plus 1/2 is what gives us 1, and so we have 1/2 times 2/3. So that also has to give us 1/2. And then the last term, plus 2 square root of 2 over 3, we're integrating psi 1 and psi 3. Of course, if we integrated this kind of thing, this doesn't go into the integration because it's an integration in x, so this just goes along for the ride, but it's kind of gives you a sense that the calculation would be time dependent if this did not give us 0. So we're not integrating over from 0 to L because that would give us 0 directly, but we know that, again, we have a definite parity. This coupled function, this multiplied psi 1 times psi 3, is an even function. It doesn't, it looks the same on one side with respect to the other. So if the total is going to give us 0, integrating from 0 to L, psi 1, psi 3, then each one they both must add up, each side must give us half of that value. And so we're integrating from there to there, or from there to there, they both must give us 0. And so there's nothing else to add to that. And so we get 1 over 6 plus 2 over 6, which is the 1/2.